Okay, now we want to find, now that we have a scatter plot, we want to find the line that goes through the data the best. We'll call it the best fit line. So I've got all these data points here. I want to try to hit as many as I can or get as close to them as I can. And what do we mean by close? See, this line here missed this data point by this distance right here, this vertical distance. Here I missed this one by this distance. Here the line is below the point, here the line is above the point, and so forth. We call those distances, those vertical distances, residuals. So the residual is your actual y value, in this case that would be 2, minus the predicted y value, the one on the line, looks like about 1.3 or something. So this guy here would have a positive residual because he's above the line. This guy would have a negative residual. He's below the line. Positive residuals are above, negatives are below. The best line that we could possibly draw is the one that minimizes the sum of the squared residuals. You won't have to know that. Our calculator does it for us. We type all the numbers in the calculator, it spits out a line that is the best of all the possible lines we could draw. So we get a line. You guys have had college algebra. You know what lines look like. Y equals mx plus b. So our y hat here, we call that y hat. That's our predicted y value. What the line says the y value should be. X is our input, our explanatory variable. M is the slope. Remember, slope is change in y per change in x. So we have to stop and think about the units of slope. Slope has units that are a fraction, units of y per units of x. So the interpretation of the slope is always going to be for each additional x, the model predicts that y will go up or down by m. Okay, you guys have had college algebra. You know what b is? What's b? Somebody tell me.
Y-intercept?
Nope. I tricked you. Y-intercept is a point. B is a number. Intercepts are points, not numbers. You were lied to in intermediate algebra. B is not the y-intercept. B is the y-coordinate of the y-intercept. That's an important distinction. Intercepts are points, not numbers. B is just a number. I'm not writing out a point there. So I asked that on purpose. I don't even know who answered that. But somebody always says that. I wanted somebody to say B is the y-intercept, just so I could say, no, it's not. So what that means is this model predicts that when x equals 0, y will equal b. And in most cases, what you'll see when we do usually the y-intercept makes no physical sense whatsoever. It's usually something ridiculous, but we're okay with that. And I'll explain why when we do an example. Our calculator will also give us R, which is called the correlation coefficient. We talked about that a minute ago. And R squared, which we'll talk about in a minute, is the percent of variability in y accounted for by the model.